I mean, I woke up at noon today. I went to bed at 4. I don't know. I've been on kind of like a late sleep schedule. I get caught up in like coding projects, and then I look at the clock and it's really late. And I'm like, oh no. Oh, got messed up. And also, I think I've been like getting over getting sick or something. So my body just told me like, no, you need to go rest. So I slept until noon today. Not proud of that. But it was really nice. Also, it was raining this morning, and I love sleeping to like the pitter patter of rain. Yes, you can't see my screen in Discord. Correct. Yep. Let me fix that. Thank you. Totally cool. Preview projector. I don't want to project to here. I will follow back like the live. What's up, dude? Yo, it is Q. What's up, Q? What up? All right, let me see. Where's my... Okay, let's go pick a question. Let's see whose question's going to get picked today. Let's go choose a winner. Spin, spin, spin. Who's going to win? Ooh, looks like... Nice. It's going to be David. Yay, congrats, David. Okay, David, we'll do your question first. And then Big C, you're probably next, because you have 100% of the votes right now. All right. Yeah, it already spun. Okay, let's pull up your video. Oh, wow. Yeah, this is statics for sure. For sure, skis. Ugh. Or we can make things like bigger. I think I want it like that. That's cool. Okay. It says calculate the moments of the 600 Newton force using the vector and scalar. Should be scalar. Not scalar with an E. It's okay. I think it's scalar is what they want to say. All right. Yeah, moments is R cross F. I agree. So R always points from, is a vector that points from the origin of your rotation to where the force is being applied. And then F is the force being applied. So I don't know what the fuck this is. Scalar method? I get it. They're saying, let me see this. Sorry. What is this? What symbol is this? G with a Jesus cross in it?
Surprise, motherfucker.
Up, what is that? Special G? That's... Oh, sorry. That's the direction. Sorry. It looked like a G for a second. Okay, my bad. It's a plus because it's positive. I see. Well, I mean, in my mind, right? The moment's pointing this way, no? I would say moment's pointing clockwise. You think it's anti-clockwise? I mean, look at this. I mean, this shit's definitely like about this rotation point. It's definitely trying to pull it this way. That to me seems clockwise, which would be negative. But again, this is the difference between like physics and engineering. It always like messes with me, like what they call moment versus what we call torque. Because then there's like, I don't know, stress versus strain or something. Because then what are they using for their distance? Oh, cool. Okay. Yeah, no, I agree with this. Well, it's actually really interesting here. Yeah, wow. Okay. Because, okay, here's how I think about moment, right? So, torque, which I write like this. Okay, so from what I understand, moment, sorry, is like static. Means like things aren't moving, right? So, in this case, you have a force being applied to like, I don't know, some weird looking flag thing, and you assume the flag is not moving, so that there's no angular acceleration. And so that means that the sum of the torques is 0. And I think in engineering, they call that a moment. Whereas if this thing was moving, which I guess the class would be called dynamics, then I think they refer to it as torque. We can also like let's ask chat. I'm actually curious about this. I'm gonna say like I'm a PhD physics person, and I have a hard time understanding questions from engineering students. I'm literally just gonna tell chat like what's up, where they use moment instead of torque or in addition to it. I think it has to do something with statics. Let's just see. I'm just curious. I'm not crazy. Right. Thank you. I'm not crazy. Sycophant ChatGPT at it again. This is mostly terminology and a context shift. Agreed. The terminology fucks with me. As a PhD physicist, I'm used to torque as R cross F. 100% cool. Which we use, yes, in terms of angular momentum, rotational dynamics, and time evolution. Engineers use it in stacks and structures. Okay. So in torque and physics, great. I all know this, and it's inherently dynamic. In statics, moment is the tendency of a force to cause rotation around a point or axis. It's the same cross product. So it's still R cross F. Okay. Okay. I think the reason they call it moment is because in statics, when things are still, or equilibrium, right? The sum of the moments has to be equal to 0, because they don't even deal with I alpha. They don't deal with moment of inertia and angular momentum. Or, sorry, they don't deal with moment of inertia and angular acceleration. Torque has a special meaning. Yes. Okay, here we go. So I think this is it. I think in... Yeah, engineers talk about, like, bending moment, which is the internal torque transmitted across the cross-section of a beam. It's not like an external torque. Okay. Okay, cool. All right. I think that's okay. So I think we kind of all agree. So this is the formal definition. Torque is equal to R cross F. Okay. You can also think of this in what they call the scale. So this is with vectors, right? You have to do cross products with vectors. The other way to do it is to say that it's equal to R perp F or RF perp. Okay. Where this is the component of R that is perpendicular to F. And then this, I guess, is the amount of F that is perpendicular to R. And I think I see how this... Yes, exactly, to where the force is being applied. Okay, so, yeah, with the vector method, right? R needs to connect from the origin to the point of the force. And in that case, as a vector, if you're going from, like, here to here, that means you're going 2 to the right. That's why the R vector is 2, comma, 4 up, 4, and then 0, right? Nothing's coming in and out of the plane. And then, if you look at F, right? F has a couple components, right? F has a X component, which in this case is 600 cosine of 40 degrees, which they found as this, right? And then you also have the Fy, which is 600 sine of 40 degrees, but then it's negative, right? Because this points down. So then this is your vector for R, this is your vector for F, and then you do the cross product, which, yeah. Torque has, yeah. Does UCLA accept A levels? I don't think so. think they... I mean, they don't even require the SAT these days, so, like, who cares? They really should. Okay. So, when you do, right, when you do the cross product, let me see. I do it this way, right? So, well, it's actually interesting how you wrote all this. Yeah, okay, I hat, J hat, K hat. I don't know why you're writing X, Y, Z here. I get it. You're trying to, like, say, like, which component of it is, but, like, really just deal with this. Bresticle says, my modern physics professor skipped relativity and went straight to chapter 3. Is that normal? Yeah, I mean, relativity kind of sucks. Special relativity, it's a mindfuck. Okay. So when you do a cross product, right, it's like this times this minus this times this, but you see how the zeros here is gonna, like, negate any component there. So even if I do this, right, if I try to find the y component, doing the determinant here is like 2 times 0 minus 459 times 0. This is also 0. So this is the only component that survives. Do you understand how to do you understand how to do a cross product with vectors, David? That's also like a question. Okay, cool, awesome. So then, yeah, so then it's just this, right? This times this minus this times this, and then you're good. So that's how to do it with the vector method. I understand that. The scalar method's actually kind of cool. Because I see what they're doing. So they're saying, they're pretending that this green force, do we know what's D? What do you mean D? Oh, how do you know, or D as in distance? Yeah, let's show it. Yeah, okay. So here's what they're doing. They're saying, okay, well, they're breaking up this green force into 2 different forces. They're saying, like, let's pretend that this total 600 newtons here, right, is really... Stream's down? Wait, what's wrong with the stream? Oh, it is down. The fuck? Twitch? It's reconnecting. It should be okay. Well, it's fine on TikTok. That's weird. Oh man, Twitch is having issues. Okay, one sec. Let me finish this question for David. It's fine on YouTube? Yeah, I don't know. Twitch is just fucking up today. Okay. All right. So, why do I hate and love math at the same time? It's a love-hate relationship. So, David, let's pretend that this green force, which, right, was to the diagonal here, can be composed of 2 separate forces, an X force and a Y force, okay? So that's what they say. They say Fx and Fy. And then they come up with numbers for that, right? Because you can break this down using trig, right, to get that. All right. So then what they do is they say, okay, but let's also come up with an Rx and an Ry. Like, let's describe the distance. Or I guess they call it D. Let's call it like dx and dy. Yeah, I understand on Twitch. I'll check Twitch in a second. So dx and dy. So in the x direction, the distance is 2. In the y direction, the distance is 4. Right? Now what they're doing is they're doing this. You remember how I said like r perp cross f? Or r cross f perp? What they're doing is they're saying, okay, for a distance rx, what's perpendicular to rx? Well, that would be fy. And then what's perpendicular to ry? It's fx. This is the same thing as r perp times f. They're pretending they're 2 separate forces, and they're finding the amount of force perpendicular to the distance. So if the distance is in the x direction, you want the force in the y direction. And then if you want the distance in the y direction, then you want the force in the x direction. And then, yeah, that's why they have this, right? Yeah, this is cool. This is negative, right? Because Fy was negative because it points down. Yeah, makes sense. Cool. Yeah. The other way I would have done this is, you could have also said, for instance, let me think here. Yeah. So you could have said that that's the scalar method, which is cool because it breaks the force into two forces and the distance into two distances. I actually haven't seen this before. The way I would do it is I would figure out what this distance r is, right? So in this case, r would be equal to the square root of 2 squared plus 4 squared, which would be square root of 20, right? Right, and if that's r, now I want the amount of force that's perpendicular to that. So I really want this. Oh, well, let's get it a little bigger, sorry. I want this. And if this angle here is 40, how do I get this angle? Let me think. Boom, boom. Like a triangle that gets formed here somehow. Let me think. All right, so it's 40 degrees from there. Oh, okay. You got to do a little bit of fun geometry here. Okay. So they're saying this is 40 degrees. So that means this is 40 degrees. Right? No. Huh. This is 40. So then this is going to be 50. But how do I find the amount perpendicular to that? Oh, it's kind of ugly. That's really ugly. Wait, how do you figure that out? Yeah, complementary angles. I think so. I'm trying to see how that works though. Right here. Let me pull this picture down a little bit so I can look at it. Yeah, law of sines might work. All right, because you have this, but then I need the 90 to this. I need eventually this. Right? This is what we're trying to get. From here. You know this is a 90-degree angle, but this is, how does this relate to this though? Man, that's really tough actually. Let me see. Maybe I can like do some fun stuff. If that's 40, no. I'm drawing a blank. This is what you get for messing with physics?
Surprise, motherfucker.
Oh, man. Oh, okay. Well, bruh, I hate torque questions. This is statics. We showed how to do it. I think, yeah, the RF thing is pretty cool. Who gave Anka soundboard?
Disqualified.
I did. I gave myself the soundboard. We could figure out this angle, for instance, using whatever law of sines stuff. But how do I get? I need this angle. That's the issue. I need this. I guess from that you could then find this. Oh yeah, this is super goofy. Okay, watch. So this, right, would be the arctangent of 2/4, right? Arctangent 1/2. And then you could figure out what this angle is from 90 minus that, right? Because this makes a triangle. And then you could do 180 minus this minus this. I just want to see what it is. I'm actually curious now. This is, in no way should you do the question this way, just because of what they gave you. And maybe, I don't know, my brain's kind of sick. I think I'm definitely fighting some sort of brain fog. I just want to see if we get the same answer, because I think we should. Okay. I'm going to brute force this. So arctangent of a half is that, right? And then I'm going to do 90 minus that. That gets me this angle, which is 63.4. So this angle is 63.4. And then I know that this angle plus this angle plus this angle has to equal 180. Right? So that plus 40 and then 180 minus it. Bingo bango, gets you 76.57. Okay, so this right here is 76.57 degrees. Okay, so if I want... so we already figured out, right, that r was equal to the square root of 20, right? Because 4 squared plus 2 squared square rooted. And then so f perp should equal 600, and then it's the sine of this angle. Sine of this goofy ass 76.57. Let's just say 76 degrees. So if I do 600 times the sine of that angle, I get 583. And so then RF perp is 583 times the square root of 20. And let's see what that is. Answer is 2609.85. Which is that what they got? It is. Nice. There we go. We did it. Okay, so that's another way to do it. Don't do it this way though. But you're very welcome. Yeah. I hope that makes sense. I'm actually gonna use this method more often. This scalar method is actually pretty fucking dope. I think it's cool actually. You break R into components, you break F into components, and then you just match the opposite ones. It's really cool. I think that's literally what a cross product is though. Right? Do you see how this is like fx with ry, and then it's fy with rx? I think we just rediscovered what a cross product is. It's cool though. All right, let me save this for you. Yeah, exactly. Well, yeah. So r perp cross f, or r perp times f, which is, I guess, yeah, it's literally just how a cross product works. A cross product always matches like perpendicular components with each other. Like, here, you can do it like, so, cross product determinant. Sorry. Yeah. Do you see here how it's like AY, BZ, AZ, BY? Right, that's a matchup. Then AX, BZ, AZ, BX, and then AX, BY, AY, BX. It's always matching up perpendicular components with each other. The difference is like there's some minus sign in there that like does some whatever stuff. Yeah. Very cool though. I appreciate the question there. Let's mark that as done. Okay, cool. And then here I'll put this in I'll put this solution here, David, in the Discord for you so you can go see it. There you go. And you get a point. Alright, let's go diagnose why Twitch is down. I'm actually curious why Twitch is down. Am I a full-time professor? I'm like a guest professor at UCLA. Like, I teach there occasionally. Yeah, let's see what's going on with Twitch today. Twitch seems to... I think Twitch is just fucked, dude. What is this? What is going on? Is anybody else's Twitch streams running right now? Let's see, down detector, Twitch. This is also why we stream on a lot of different platforms. Oh dear. Yeah, that'd be a big spike.
Oh shit, not good.
Yeah, that's a big spike. Okay. So I apologize for y'all trying to watch on Twitch. Twitch is apparently down. When it comes back, we'll take a look at it. Thank you very much for the help and for creating this. It helps a lot surviving the semester. Fuck yeah, David.
Bing bang.
I'm glad it helps you out. I'm really happy. That's the whole reason we do this. All right, let's go pick another person. Mike's been hitting the upvote a lot. Okay, Mike. I see you, Mike. All right, let's spin. See who the winner is. What's better, chemical or mech E? If you want money, probably chemi. Okay, anonymous user. Dude, Twitch is dude, this is too funny, dude. I'm taking a screenshot. Oh, I can't show you guys because it's on a different PC. TikTok analyzed what I was saying and says, your live has been restricted because it contains themes that some may find uncomfortable. Harassment and bullying?
You don't know stuff, Aaron!
What's the harassment and bullying? Excuse me? Who am I bullying Twitch? It's so crazy. TikTok analyzes everything you say during a live stream. It's really crazy. Okay. All right, let's see. Next vote. Okay. A circle of radius r is surrounded by 3 circles whose radii are all 1, 2, and 3, all externally tangent to the inner circle and all externally tangent to each other. Great. What's up, Joel? Yeah, isn't this cool? Okay. What is R? Okay. It's kind of fun. Wait, you did this? Oh, Joel. Okay, you want to help me out then? Anyways, okay, so I'm guessing this one has a radius of 1. Here, let me like draw some like lines, right? I usually have to like draw lines for this to work. Tell me we need a clue. Appreciate. All right, I might need a clue in a bit here. So stay ready. Stand down and stand by. Okay, this is 1. I watch your live while making bracelets. That's sick. Do you want to send a picture of one of your bracelets? If you join our Discord, you can join the chat, the stage chat. Just like dump pictures as long as they're like appropriate bracelets. I don't know. You ever see those bracelets when if you go to like Mexico and stuff, and they have like horrendous words on them? Like, I don't know. Butt smasher or something. I don't know. Okay, this is 3. All right, let's think. If they're all tangent, that usually... So, when something's tangent, that means that, like, the angle from, like, this and this is 90 degrees. So, I'm thinking I can, like, make, like, a... start making some triangles, probably, right? I hate how small this is. So tiny to see this. Okay. I'm gonna draw more lines. Maybe that'll help things. Also, let me make these like a little bit thinner. Oh, there you go, OBD. Let's check out your bracelet. Oh. Sick. That's a cool bracelet. I like that. That's a cool bracelet. I think I can see it on this one. There you go. Yeah, now I can see your bracelet. Look at that. And it just stays on, I guess. See, oh, it does loop together probably. That's pretty. I like the butterflies. It's cool. It's wire. Nice. Do you like, where do you give them out? Do you like sell them at like a farmer's market or something? That'd be cool. People, or like Etsy. Etsy's great. I have an Etsy. I sell stuff on Etsy. Ooh, I think I maybe see something here. Wait a minute. If these... Why is my TikTok age restricted? I don't know. They said they temporarily restricted it because they said I was bullying on my stream when I think I was just getting mad at Twitch for being down. They said that was bullying, apparently. It's hilarious. I don't know. Yeah, okay. Whatever. Keep kids safe or something. Oh, I think I see what's going to maybe happen here. Yep, I see it. 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 All I had to do was do this. Pretty sure this is all I had to do. What am I solving? Good question, Roshan. If you ever want to see the exact question, so this is what it is. But if you ever want to view like what the question is, if you go to our website, actualofficehours.com, and then you click here on live queue, that'll show this, and then you can click on the top one, and that's the question. Oh, they don't like when you mention other... Well, I was mentioning that other platforms are down. I was mentioning that the platform that shall not be named wasn't working. Okay, so this is 2. Okay, very cool. Oh, dude, this is a 3, 4, 5. Oh, this is sick.
That's dope.
It's a cool question. What's up, video game wizard? So look at this. So this makes a... Well, I hope it's a right triangle. Can we say it's a right triangle? That's actually a good question. I think we can. Because if something's a 3, 4, 5, it has to be a right triangle, right? Yeah. There's like no way it could have. Yes, since 3, 4, 5, right? Yeah. The purple app? Oh, that's too funny. Okay, so yeah, this is a 3, 4, 5. Very cool. Okay, 3, 4, 5. Okay. And then... Fascinating. This is in the center somewhere. Is this in the circumcenter, though? Because what I'm trying to figure out is I'm trying to figure out what R is. I'm trying to figure this out, right? This is where I'm sure Jeff wants to make like a coordinate system or something, right, Jeff? Jeff, I know you do. Oh, I'm close. I'm so close. I'm trying to think what I want to do. Because I see this is R plus 1. Right? That's this distance. And then this distance is R plus 3. And then this is R plus 2. And then... Right? Let me draw that. Let me show you what I'm thinking about. I know it's not exactly straight, which is the problem. Because I didn't have the exact centers of these circles. It's multiple choice. So you could find the area of the triangle and subtract. Draw the line to the center. I agree, Joel. Yep, so I see this. Right, this is R plus 1. Because it's R to get to here, and then it's another 1 to get to here, because that's a radius. And so this here is R plus 2. And then this one here is R plus 3. Okay. Do I want to use law of sines? No, he says no. Don't do that. Too long. Okay, too long. Too long. All right. I won't do it. I mean, because what I see is like this angle, right? And then this angle, and then this angle. Those are similar inner triangles. Are they similar inner triangles, though? They have to have the same angle. To be similar angles. Similar. Need a clue? Yeah. I don't think you can prove the similarity. I want to do law of cosines. Really what I want to do. I really want to do law of cosines. But then I know that, like, I want to do law of cosines for each one of these. And then know that all the angles add up to 360. Yeah, I could do that. See, that's my American brute force freedom eagle cheeseburger method. Is just write the law of cosines for each of these angles. It'll be in terms of r, and then we just sum them all up to 360. Is there a simpler way to do it though, Joel? There is a simpler way. Tell me, fair Joel, what is the simpler way? You can give me a hint. I see triangles. There is a formula. Oh, okay. Is it like a circumcenter formula? But what I did was do coordinates. Oh, okay. It's very unknown. Well, I don't know if I'd be able to do it then. It's very unknown. You know what this reminds me of? One of my students posted this. His name's 1K. He posted this in my Discord. This is hilarious. Finally, so someone has submitted this question to me before. This is a JEE question about the rotating discs. Someone gave me this once on an office hours, and like,
Jesus Christ, motherfucker.
I've banned doing JEE questions just because they're absolute nightmares, and I don't think they really like teach you much. They just teach you like math sucks sometimes. In this case, I think this is physics is what it was. But dude, this guy solved it in 6.5 hours. It's a 6.5 hour video of him solving it. Which is nuts. Dude, look at the amount of madness that's going on here. But what I do respect about this question that this guy does in 6.5 hours is he just shows you that if you eventually keep hammering away at something, you will get the answer. It just depends how long you're willing to keep hammering. And I guess this guy hammered at it for 6.5 hours. So how JEE, the exam, works, because you don't have 6.5 hours to figure out that question, is that you have to basically know either like obscure unknown formulas or have memorized the solution so you know what to do. But in the real world, how you would do that is you would like just keep trying until you get it. The question is in suggested vids. Where would you see it? Oh, it's cool. Well, our live stream is in suggested vids. That's actually kind of fun. People just skip to the end and be like, "Did he get the answer?" Okay. Let me see. Joel said, "Set the radius of the circle set like the radius of one circle equal to 0, 0." Okay. Like if I set this equal to 0, 0. Jeff would be really happy. Jeff loves coordinate system solutions. He's a big fan of these. Set the other one. Oh, you want me to set this one maybe? You have to look at it in a different perspective. Okay. All right. Whatever. Okay, let's set this equal to 0, 0. The real question is, are you single? Everybody's single. Have you seen the birth rate like crisis? Dude, nobody's in a relationship. Or they're not in one for very long. Okay, if this is 0, 0. I'm trying to see what you're saying. So, do we assume this is also straight that way? How can I assume that this is, for instance, like negative r plus 1 comma 0? If I weren't single, I'd be in a mental hospital by now. Oh dear. Can I turn the figure around? Oh, I see. Wait, you want me to like rotate it like this way, for instance, and call this 0, 0? Okay, cool. That's fine. And then, I see. We're going to call this position here, right? This is what we're looking for. And that's r plus 1. I think I see. I think I see where this is going. So this right here is r plus 1. Oh, wrong thing. And this right here is r plus 2. And then the other one's r plus 3. Okay. And then I guess I know that this coordinate here is negative 4 comma 0, right? And then that this coordinate is 0 comma 3. Okay. Well, I see that like here to here, right? This vector to this vector, I guess technically is equal to that, yeah? Do you want me to do it in terms of vectors? Because I could see it that way. Which I think you're basically doing law of cosines at this point. Nah. Okay. It says nah, dude. Just set it as 4 comma 0? Well, wait. Well, this is negative 4 comma 0. No negatives because... Okay. Sure. But then this is kind of goofy. Now I'm calling the positive x direction this way. Sure. I mean, you can. Turn it around. I don't know if it's that simple.
Surprise, motherfucker.
Okay, make it negative. I'm cool with it being negative. I'm pretty sure it's negative. Let me try. Yeah, Joel, what is this now? What is this? What you led us here. I'm tempted to do law of cosines. I'm tempted. Joel says, yo, okay. Because I'm about to start doing law of cosines. What do we remember about the circle coordinate? What do we remember about circle coordinate? X squared plus y squared equals r squared. Correct. But, yeah, this thing... I don't know if... It doesn't really go through there. Yes, I remember that. Yeah. Are you saying this is the circumcenter, though? No? Okay. Since we have the coordinate, we have 3 circles. Which makes 3 equations. 3 variables. Oh, I think I see what you're saying. You're saying this. So x minus h squared plus y minus k squared is equal to r squared. So, okay. If I wanted to say, I think I see what you're saying here. It's very interesting. You're saying if I were to create a circle here, right? That would be x squared plus y squared is equal to r plus 1 squared, right? If I were to make a circle here, I can like make that a little bit better. And then I think we're just gonna find where they all intersect, right? That would be x squared plus y minus 3 squared is equal to r plus 2 squared. I got it? Okay, cool.
Yeah.
This is kind of like law of cosines. And then this one... Yeah. I'm gonna make it a little bit bigger. This is x plus 4, right? Because it's located negative 4. So that's going to be plus 4 squared plus y squared is equal to r plus 3 squared. Okay. So now what you do is you solve these 3 equations. So yeah, now you have 3 equations and 3 unknowns. Okay, cool. I don't know if that's really going to help you, though. Looks kind of messy. How do I solve 3 nonlinear equations of each other? Yeah. Well, you know what you could do at this point? Since it is multiple choice. I guess you could try to plug in values, maybe. We could just see if that makes sense for R. Is there a way to, like, combine these so that they cancel? Like, I could combine this one with this one to get something just in terms... Use the vector method... and then take the dot product to find the angles. I see what you're saying. Like, write these as vectors. I mean, that's law of cosines, which may be more solvable. But I think you're going to get the same thing. Let's think about it. You're still going to get... No. Yeah, wait. Subtract the first one with the second one, and then the first one with the third one. Okay. All right, let's do a little bit of the algebra. I feel like this gets messy. All right, if we do 1 minus 2, that gets me y squared minus y minus 3 squared. Or, yeah. Y squared minus y minus 3 squared is equal to r plus 1 squared minus r plus 2 squared. Breskel says just split the center triangle into two separate right triangles and solve. 2 separate right triangles. Oh. You mean like this? I see. Breskel's is saying, what if you just did this? And then what? You know, this squared plus this squared equals this squared, but then this squared plus this squared equals this squared. Can you assume that's 90? Let's try it. I'm actually curious. If it comes up with one of the answer choices and we say it's correct, then it is. Technically, yes. Interesting. I wonder why you can say that's 90. That to me doesn't seem sound, but whatever. Okay, so if you did that, you have 2 squared plus, I don't know, call it like a squared equals r plus 2 squared. And then in this case, you have 1 squared. Yeah, because it's a straight line, so perpendicular line coming off of it is 90 degrees. Oh, correct. I guess, yeah. These are radii, so they have to have a 90. It's just that 90 also passes through the center of this circle here. That's where I start to get a little cagey. I'm just like, I don't know about that. Okay, but then this would be 1 squared plus a squared equals r plus 1 squared. And then I think we get the same here, right? So if I subtract these two, I get 4 minus 1, which is 3, is equal to r plus 2 squared minus r plus 1 squared. So 3 is equal to r squared plus 4r plus 4 minus r squared minus 2r minus 1. Cancel. 4r minus 2r is 2r. 4r minus 1 is 3. So 2r minus 3, blah, 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 equal to 3. So 6 equals 2r. Well, that's not good. R equals 3? I don't like that. I don't think R can equal 3. Sorry, wait, what did we do wrong here? Sorry. 4 minus 1 is 3. That cancels. R squared plus 4r plus 4 minus r squared minus 2r minus 1. Oh, wait, sorry. This is 4 minus 1, which is 3. Oh. Wait. I think we have this wrong. Sorry, 4 minus 1 is not 3. 4 minus 1 is... Wait. Yeah, no, wait. 4 minus 1 is 3. Brain today. I'm definitely sick. I can tell I'm sick. I just hate when I make stupid fucking mistakes. 4 minus 1 is 3. Wait, what? Wait, that gets me 2r is equal to 6. R can't equal 3. That doesn't make any sense. I don't think this works. Unless I screwed up, right? Wait. 2 plus a squared. 2 squared plus a squared, right? 1 squared plus a squared. I'm not crazy, right? I don't think I'm crazy. Yeah, I don't think that works. 2r. Yeah, no. I don't think this works. Let's go back to like what he was doing here. Joel, big dog. Big dog. Alright, let's do 1 minus 3. Where did the 4 come from? Oh, it came from just expanding this. R plus 2 squared is r squared plus 4r plus 4. Right? Because I know this is r plus 2, right? I was doing this squared plus this squared, where I was calling this thing a. Okay, let's see. 1 minus 3. So now you're going to cancel the y's out. So that's going to be x squared minus x plus 4 squared equals r plus 1 squared minus r plus 3 squared. Okay. And then what do you want me to do with that? Because now I have 2 equations and 3 unknowns. Oh, actually I don't, right? Sorry. This will cancel out. I'm stupid.
You're not that guy, Cal. Trust me. You're not that guy.
Right? Because look. Okay. Actually. Yeah, wait. We just had to do one of them, no? Yeah, we don't even have to do both of them. Sorry. Yeah, look. Because this. Okay, we don't even need this. Whatever. Just go down to this. Because this is y squared minus y squared plus 6y minus 9 is equal to r squared plus 2r plus 1 minus r squared minus 4r minus 4, right? This cancels. Oh, we actually do need both because I'm going to get y in terms of r and then I'm going to get x in terms of r maybe. Sorry, what's going to happen here? This is cool, whatever. So I get 6y is equal to, and then 2r minus 4r is negative 2r. 1 minus 4 is negative 3. Negative 3 plus 9 is 6. Right? Is that what I get? So y is equal to negative 1/3 r plus 1. And then from this one, by kind of the same logic, let's see what I get. I'm going to get 8x, right? Should be a quadratic. So let me just, I got to write this out, sorry, my brain. X squared minus 8x minus 16 is equal to r squared plus 2r plus 1 minus r squared minus 6r minus 9. Cancel. Negative 8x. Wait, is the minus okay there? Yeah, the minus is okay that time. Equal to negative 4r plus 1 minus 9 is negative 8. Negative 8 plus 16 is plus 8. So then I get x is equal to 1/2 r minus 1. Okay. And then I think what I can do is I can say that, oh, but x squared plus y squared was equal to 1. Was equal to r plus 1 squared. And so then, am I just going to, like, square these again? And see what I get? So that's 1/9 r squared minus 2/3 r plus 1 plus 1/4 r squared minus r plus 1 is equal to r squared plus 2r plus 1. Okay. This is messy. Well, at least the plus 1. Well, no. Oh, whatever. This one cancels with this one at least. Minus r. This becomes 3r. And then I just have ugly fractions here. 4/36 r squared plus 9/36 r squared minus 2/3 r. And then plus 1. Then we say minus 3r from here, and then minus 1. No more minus. And then minus r squared is equal to 0. Okay. So that's 13 over 36 minus 36 over 36. So negative 23 over 36 r squared minus 11 over 3r plus 1 equals 0. Okay. I'm just going to put this in the chat. I could do the quadratic form. I don't really want to. Solve for r. See what he gets. Dun 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 dun. Let me make sure this. Oh, well, no. It thinks my R's are Z's. I don't think this turns out to be a nice quadratic, though. Yes. Negative 23 over 6 minus 11 over 3 plus 1. Bing, 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 bing. 6 over 23 or negative 6. So the answer is 6 over 23. Is that one of the answer choices? It is. It's answer choice B. We did it. Congrats, guys. Wow. That question took me 36 minutes to do.
Disqualified.
But it's okay. We persisted. We persisted. Which I think is cool. Usually I will like cut questions at 20 minutes, but this at least was making forward progress. Albeit it was kind of a mess. But thank you, Joel. I really appreciate all the hints along the way. That was really, really fun. I liked the creating the circles and then finding the intersect. That was really fun. It's a really cool technique. www. Yeah, we did it. All right, cool. I'm going to go post that question in our Discord. If you want to go see it. All right, let's see. Mike somehow has 5,000 votes. Crazy, dude. What? 6,661 votes? How did you do this, Mike? Oh, no. Oh, Descartes formula? Yeah, maybe. Let me see. Sorry if Twitch is still down. Is everybody's channels down on Twitch?
We provide...
No, some people are live. Oh, they're live. Okay. I wonder why we're not live. It keeps saying reconnecting. Here, let me see if I can fix this. Hi, I'm Elon Musk. Imagine with 6,660 votes I don't get chosen. There's a point. There's a chance. Let me. The stream might go down temporarily on YouTube. Just stick around. It'll come back. I'm gonna try resetting on Twitch real quick. Okay. I think we're back. YouTube still going? Then let me make sure my chats are working. YouTube. Cool. All right, we're still going, it looks like. Ooh, not much of a delay. This is fun. We can go see Infinite Mies. Hi, Elon. And I think we're good on Twitch again. Yep. We are good. Yep. We are good. Infinite Mies. Okay, cool. All right. All right, good. Twitch is back to working. Let's see. Let's spin, see who's gonna win on the next one. Preparing to spin. The votes are intense. Okay, Mike, it is gonna be you.
Oh, yeah.
Bro's at 8,700. Yes. Do you have a script to just hit it every 3 minutes? Or did you find an exploit? Please let me know. As Narosky knows, my code is spaghetti at this point. It works for the majority of things, but I know people can find exploits to things. You did it physically? Okay. I mean, it is a compounding thing. So every time you hit upvote on that website, it boosts it by 15%. So 1.15 if it hits repeatedly over the course of what we've been streaming for probably I don't know how long, like an hour and a half every 3 minutes. Yeah, you could get up there for sure. We can actually do the math of that. Here, I'm gonna pull your question in and then let's see what you got. This is already a very difficult question. What's up, Fanatic and Narosky? Maybe I need you guys to come help me on this one. This one looks pretty crazy. The intersection of 4 symmetrical parabolic regions inside the board. It is the union of 8 symmetric copies of region A bounded by x is greater than or equal to 0. Y is greater than or equal to x and y is less than 1 minus x squared over 2. A short calculation shows that the bounding curves y equals x and y equals that intersect it there. Thus, the desired probability is 8 times the area of A over the area of the board is equal to 2 times the area of A, which is equal to that. Show that every composite is expressible as xy plus xz plus yz plus 1, with x, y, and z are positive integers. I have no clue what this means, but I see 1988, and this makes me think it's one of the crazy like Putnam questions from like the 80s. Good luck. I want to do a little bit of math real quick in terms of like, so wait, it's 4:6. You submitted your question at 4:16. Narosky says that's fascinating. I'm glad you think it's fascinating. I think it's a nightmare. Do you think it's something possible for you to solve, Narosky? I'm just curious. And then what is to the time right now? Oh, so it's 5:20. So let's say about an hour. 1988, sure. Oh, these are 2 different things. Oh, these are 2 different questions. Oh. So wait. Shush. You're in my chat right now. Shush. Do you want to do this one or do this one? The top one or the bottom one? I feel like the top one is missing things. You want to do the top one. But I think it's missing a question. What is the top one asking for? Like, I feel like there's like missing information up here. But let me think about this. Okay, so like 1 hour, right? And if it's every 3 minutes you can click, so that's 20 clicks, 20 upvotes. Do the bottom one? Okay. I just want to kind of see how this works. So if it's 20 upvotes and you start with 18 and it's exponential, right? So this is 18, 1.15 to the 20th. Let's see, what would that be equal to? I want to see if it gets to like what you got. So 18 times 1.15 to the 20th. Well, that would only be 294. Interesting. What's up, Riley?
Good job.
I still don't know how you got to 6,000. Okay. But I guess it is also increasing linearly. I forgot how the code is written. I think also every minute it gains like 3. So that would also like increase your chances. Yeah. Okay, let me see. A positive integer is a product AB with A. Oh, what's up, Zev? Lucky number 7. What that movie, Kansas City Shuffle? Lucky number 11? The Kansas City Shuffle? Someone's had to say 6. Lucky number 11, yeah. That's a great movie. Confusing, but it was great. Yeah, it was a great one, classic. Let's see. Show that every composite number is expressed as xy plus xc plus yz plus 1 with x, y, and z. I'm gonna let me help out Big C real quick. Well, if people want to chew on this one, I'll come back to it. Okay, yeah, let's catch up, dude. I sent you a message on Discord. Let me help out Big C because Big C submitted their question at the very beginning, and let me help them out real quick on this. Okay, because I think they just needed to find the area of this. Is that what the question was? Set an integral, find the shaded area. Yeah, okay. So this is a case of where if you're trying to find the area between two curves, you usually need like a top function and a bottom function. The issue here is that when you're looking at it this way, the top function is the bottom function. Because mainly this isn't a function, right? This fails the vertical line test like horrendously. So in this case, you need to, instead of integrating in terms of dx, because these things are not functions, you need to integrate in dy. So integrate. Let me tag David so he knows I'm doing it. Big C. Where's Big C? Okay. So let's integrate in terms of dy. Gladiator said, I had my calc test today and it went mostly well, but I realized after I made one distributing error, hopefully one off. Yeah. Yeah. Okay, let's equal 1. Let me do this one will take like 2 minutes for me to do, and then Neurosk, if you want to help me with that one, I'm down to like check it out. I don't know what a composite number means. My math literacy level these days.
Oh shit, not good.
Okay, you want to integrate with respect to dy. Now the integral goes from, so now if we're going this way, we're going to go from y equals 0 up to y equals 3. Right, so we can just write here, right? So right now, we know we're going to go from 0 to 3, dy, and then it needs to be the top function minus the bottom function. This is where you got to like kind of like shift your head a little bit. So watch, we can rotate this. Let's rotate. Ooh. Okay. So this right here is now the top function. And this right here is now the bottom. But because we're doing integral dy, right? Because we're traveling this way, dy, I need these functions to be in terms of y. So in this case, the top function... Oh, they already gave it to us, actually, right? X equals y squared minus... Yeah, okay, so this one is y squared minus 4y. And then this one right here, so you can say minus... And then this one was 2y minus y squared. Sorry. That's... It'll just be the negative? Oh, yeah, sorry, because this is negative y. Oh, thank you. Yes. No, I fucked up. Okay, no. Let's fix that. Totally right. Sorry. Yeah, I knew I did the rotation wrong. Sorry, this is what I want. Wait, no. This is what I want. There we go. Okay, cool. There we go. Okay. This is big C's. Big C's real quick. And then we'll do shushes. I'll do yours. Neurosi's gonna help me out. Okay, so this is dy. Okay, so the top function is now the red one. Top. Bottom. So then, how did we rotate this again? Rotate. Put a little picture. Rotate. Okay, cool. There we go. All right. So, the red one. So that's 2y minus y squared. And then minus the bottom one is y squared minus 4y. That's integral from 0 to 3 dy. Okay, so now this is easy to do. The important thing is that I know dy is going from right to left, but it's going from 0 to 3. So because it's increasing, I don't have to like do funny business with negatives here on the integral. It is correct, for instance, like the integral from 0 to 3 is the same thing as the negative integral from 3 to 0. That's because you're going from high numbers to low numbers. It's like the opposite direction. Okay, so then we can just write this out. Let me just do this. 0 to 3 minus y squared, so that's negative 2y squared. And then minus is plus 4y. Plus 2y is plus 6y. And dy. So then integrate. That's negative 2y to the third over 3. Plus 6y squared over 2 from 0 to 3, which is going to be equal to negative 54 over 3 plus 54 over 2. That's actually pretty cool. Right? Did I do that right? I think I did. Cool. Yeah. We're going to simplify this a little bit. Plus 27. But then 27 is the same thing as 81 over 3. So then your final answer is, 27 over 3. Which is equal to 9. Oh, beautiful. First term is minus 18. What? Where's the minus 18 coming from? I took too long to type. Oh, negative 54 over... Oh, yeah. Wow. Dude, I'm dumb. Yeah, that's just... Yeah, okay. Yeah, duh. I don't know why I did this. Okay. All right, whatever. Cool. All right, it works. Thank you, guys. Yeah, I have brain fog today for sure. I'm trying my best. Okay, that was big C. Big C. So that was question number 2. Okay. Not your friend. What's up? I haven't seen you in a hot minute, dude. What's cracking? Okay, let's try to do this one. This came from Shush. Narosky, if you want to come on the stage, say hi. Oh, you've been busy with A-levels. Oh, good luck with those. Great for getting into uni. Okay.
Yo.
What's up, Narosky? How's it going, dude?
It's going all right.
Nice. Okay. A composite number is a... So, composite just means positive integer, I guess, yeah?
So composite is just a number that isn't a prime.
Oh. Oh, okay. Is a product AB with A and B, but not necessarily distinct integers.
So yeah, it's basically saying that a composite number can be broken down into its prime factors.
Got you. Okay. Got you. Okay. But not necessarily distinct.
Yeah, and not... Yeah, so you can... so a composite number, 9 is a composite number because it's the square of 3. So A and B would be 3 and 3, and they're not necessarily distinct.
Okay. Yeah, okay, cool. So, yeah, I think all integers are composite numbers, right? Because can't you just do 1 times it? Is 7 composite or no?
Well, no. So A and B should not be 1.
Got you. Okay. Okay, got you. Okay, so composite number means not prime.
Yeah, so
okay,
composite, think about what composite... Yeah, so composite would mean not prime, basically.
Beautiful. Okay. I think I understand that now. Why couldn't they have just written that instead of saying is a product AB with A and B not necessarily distinct? I feel like that's just confusing.
Surprise, motherfucker.
Just say it's not prime.
Well, it's not confusing if you understand the point. Like it's leading. It's not confusing.
It's leading. Okay. Okay. I like that little mindset shift. Okay, they're leading us towards something. So they're saying show that every composite is expressible as xy plus xz plus yz plus 1 with x, y, and z being positive integers. Okay.
Yeah, so if you notice that is a cyclic product, that is xy plus yz plus z.
Yes, it is cyclic, right. We're pairing them all up is what we're doing. Yeah.
Yeah.
It's like a round robin.
Yeah. So my first instinct is to play with variables, and I just gave a few values. For example, I tried a few values in my head, and I settled on z equals 1 as an example.
All right, so let's just try z equals 1. Let's see what we get. I like that. So Narosky's using his intuition, say, let's try z equals 1. Z equals 1, I get xy plus x plus y plus 1, right?
Right, yeah.
And that has to equal a composite number.
Yeah. Can you figure out... This is already a composite number, but can you figure out why?
Okay. It's a product. Oh, maybe do I want to factor? Maybe I could factor out x. So x y plus 1 plus y plus 1. Oh, this is x plus 1 y plus 1. which is two things multiplied by each other. Oh, that's cool. Oh, that's fucking rad.
Careful. X plus 1, y plus 1.
Yeah, sorry, not x plus y. Sorry, my bad. Yeah. That's what I meant. Yeah.
Yeah.
Yes. Oh, very cool.
So this is already of the form a times b. So our a is x plus 1 and b is y plus 1.
Yeah. Okay. Cool. Okay.
So then x, what would x be in terms of a?
X would be equal to a minus 1.
Similarly with y.
Yes, and then y is equal to b minus 1. Okay.
Notice how a and b are integers greater than or equal to 2. Right?
Sorry, a and b are integers greater than 1, right? Because I can't have x being 0.
Yeah.
Okay.
So x and y are both positive integers.
So for x and y to be positive integers, a and b must be greater than 1, and also be integers.
And
Okay.
indeed they are, because that's what the problem says.
Right. We said that this times this is a composite number. Okay.
And this is basically the conclusion. We have found that x is equal to a minus 1, y is equal to b minus 1, and z equals 1 gives our satisfies our initial conditions.
Okay, so this satisfies the initial conditions. Okay, I see. And then it's I'm just trying to see the logic of this. So every composite is expressible as that, with z being positive integers. So we said, well, if z is equal to how do we show that every composite number can be formed like this, though?
This is why the argument at the end is so important, because we have already found the form that they are in. We just need to explain why every composite number can be expressed this way. And this is done by underlining the fact that a and b are both greater than or equal to 2. And y, both greater than or equal to 1. So they are positive integers as the problem requests.
Oh, okay.
And that is sufficient to prove what we had to prove.
Oh man, see,
so for every composite integer, this happens.
That's the mind fuck for me, dude. And I get that that's the most important part, and that's like the hardest thing for me to wrap my head around. Let me think.
Yeah, it's like, it's so little, but if you don't include it, it's it just misses the whole point. Like you've done a few calculations, and so what?
Yeah, it's like tying the whole pie together. It's like wrapping it up in the bow. It's just like, yes, now we wrapped it. It's nice. Okay. Yeah. One sec. Show that every composite is expressible.
I said this was fascinating because I don't remember ever seeing this pop up anywhere, but it's such a cute concept.
I agree, it's cute. I want it to be cute. This last part is messing with me. Okay, one sec. Try z.
I do remember at some point seeing that there is a similar result. I thought of this for a split second, but I don't think it has any correlation. The same result can be proven for the fourth power of like if you add a to the fourth plus b to the fourth plus c to the fourth plus d to the fourth, all positive integers, that would result in a composite number.
Ooh.
I believe I'm not lying. I hope I'm not lying.
That's crazy. Oh man.
Yeah, from what I remember, I've seen this once.
This is so... we call this like real analysis, right? This is like number theory stuff.
Yeah.
I feel. Yeah. It's so cool.
This is
it's
number
like,
theory. Yeah.
it's the underlying like structure of the mathematical universe. That is very cool. Okay. I'm gonna say this is done, but I'm gonna take some more time in the future to try to like really wrap my head around this. But I really like this. This is I got this part. I felt really proud of myself when I was able to go from this to this and then be like, oh, but this is the definition of a composite number. I think the last part that I have to kind of like stew on is the wrapping the bow. Yeah. Wait. Mathematic Fanatic says 2 to the 4th plus 1 to the 4th plus 1 to the 4th plus 1 to the 4th equals 19.
Surprise, motherfucker.
Yeah, I think maybe A, B, C, and D have to be greater than 1.
Greater than 1, I believe so.
Yeah, okay. Let's say like 4 A, B, C, and D are greater than 1. Yeah, you can't do that. Okay, cool. Cool question, Shush. Appreciate it. It's so fun in math when you do this cool, like, again, this was just algebraic manipulation, right? Like basic, do I know how to factor things? And then you manipulate it to look like the very thing that you're proving. I think that topic and that theme comes up a lot in mathematical proofs. Cool. Okay, let's see. I want to know how you guys are getting 3,000 votes. Are you guys really just clicking it? Is that really what you're doing? That's all you have to do? I guess it has been an hour. Okay. That tells me I probably need to change the multiplier to make it a little bit less. This is cool. We're making patches, right? We're doing, they call it like, you know, rebalancing. You know, if a weapon is like too OP in a video game, you're like, okay, we got to rebalance that. Like, we can't be running auto shotties everywhere. So I think I need to change the upvote so that it's not as consequential. Maybe I need to change the percentage, or I could change the rate. I think I like the rate though. I like you guys like continuing to click it, but I think I need to change, I think I need to change the percentage of the boost. I think as I have it, I think it's a 25% boost maybe. So I can see how that compounds pretty quickly. 85. What's up, Narosky?
Sorry. Did you get around to trying the limit problem I posted last time? I went to sleep, but I didn't follow.
Oh, you're okay.
Along.
I don't think we did. Was it? Where was it? Oh, you posted it in the chat somewhere, right? Oh, way up here. I'm gonna have to go find
It was in chat.
Oh, this one.
Yeah. Yeah.
No, we didn't. Let me do one of their questions, and then do you want to come back and do this one afterwards? I think this would be fun.
Yeah, sure.
All right, let's do it. Okay, let's roll the choose the winner for the next question that we're gonna do, and then we're gonna do a fun Narosky question. Let's do it. Spin, spin, spin. Who's gonna win? Poor DM is just like in that very, very tiny sliver. I love that they're still fighting against each other. It's a battle of the titans. And it is gonna go to Breasticles. Okay, Breasticles. Cool. Okay. And then we'll do this fun little limit question. Breasticles, what? You got stuck at the differential equation? Okay. What is the original question, though, by the way? Sorry. I is equal to this. Not super familiar with Green's functions. Me neither, honestly. So it might be difficult. Sorry, let me move this over. Oh, okay. One sec. This might be outside my wheelhouse, breasticles, because I haven't done PDEs. Okay, let's see. You're trying to solve this, I think is what you're trying to solve, right? You're trying to solve at the end of the day. 0 to pi over 2. And then I know there is like a Feynman's strategy or whatever, Feynman's method. Okay, this is what we're trying to solve. I see. Okay, so let's see what you're doing. So you're saying that, let me call that function I. And then I prime. So the derivative of an integral, right, means... Wait, wouldn't you plug this in for theta? Or, sorry, what's it with the relationship? Oh, wait. Never mind. Yeah, sorry, what's the I prime coming from? Is this di d theta? Oh, you derive it with respect to alpha. Oh, I see. All right, so, okay. You're trying to get this. So then you insert alpha. Got you. All right, that's cool. Yeah, okay. No, I see how you're doing it. So you create a new parameter alpha. And you say from 0 to pi over 2 e to the negative alpha tangent of theta d theta. Cool. And then you take the derivative, the partial with respect to alpha. So, sure, that pulls down a tangent of theta, or a negative tan theta, and then you get the same thing. I see, and then you do the second derivative. So that pulls down another tangent of theta. So then you have tangent squared theta, e to the alpha tangent theta d theta. But tangent squared is the same thing as secant squared minus 1. Okay, cool. Oh, okay. I see. And then you're left with the original integral. Oh, okay. Okay. So then I double alpha plus I alpha. This is actually really cool. Yeah, this is I want to see what happens. Okay. Is that equal to that? Okay. Oh. But then... But the derivative of tangent is secant squared. That's so cool. So now you have e to the u du. Which is just, yeah, e to the u. Or negative e to the u. Sorry, there's a minus there. This is very cool. Opal and Sage, love your face. Thank you, dude. That who's dumping all the bits on me. Thank you. Alright, does that work? Sorry, tangent of pi over 2 is... Was that infinity? Wait, what? Sorry, what? Oh, but you have e to the 0 as well. Okay, got you. Okay, it's 1 over infinity, which is 0, and then you have 0, which is 1. What's up, 1K? Okay, cool. I will trust up to this. Great. Okay, so then you have I double prime plus I is equal to 1 over alpha. So then this is a differential equation. Very cool. I don't know what's going on in my TikTok chat, but I'm here for it. Okay. Okay. So then you need to solve this, right? Is that what we're saying? Now we got to get to this. So this is, but it's a partial differential equation. Let me think. That I don't know. I never took PDEs. But maybe we can learn from chat. E equals MC squared equals pi equals love equals nature equals U equals everything.
Yeah.
Appreciate that. Yeah. Okay. Yeah, it's in terms of alpha because it's non-homogeneous, right? Yeah, this is the problem. If this was equal to 0, I feel like this would be very solvable, right? That would just be the wave equation. Because you have the second derivative is equal to the 0th derivative. Okay. Well, let's see what ChatGPT does. I'm curious. Maybe we can learn. Solve this using Feynman's method. Let's just see what he gets. Ba, ba, ba. Yeah, I don't know about Green's function. I haven't done much with Green's functions. Come on, chat. You can figure this out. I know you can. Don't make me go to Gemini. Don't make me cheat on you. Don't make me cheat on you. Differentiate the integral sign. I hardly know the integral sign. Here, let's integrate exp, what was it, to the negative tan theta d theta from 0 to pi over 2 using Feynman's method. I don't know. This is still like trying to. Okay, here we go. Feynman's trick. Oh, it's called the Leibniz integral rule. Okay, cool. So, yes. Okay, we get to here. Yep. Apparently this is what it is. This is what I hate about DiffyQ. It's just like, well, if it looks like this, then it's this.
You done messed up, AA.
And you're just supposed to, like, remember that. I know there's ways to derive it, right? There's, like, all the different tricks. Okay. And then we're doing it a equals 1. Oh, yeah. Because here the whole time, right? Alpha was equal to 1. Okay. What's up, Morosky? What are we typing? Okay, so I don't know what these special functions are. Like SI and CI. I've never even heard of these. What? What is SI and CI? Is anyone in my math community here seen these functions? Yeah. Show me the I is equal to CI. Yes, but what is CI and SI? It's like, is it sin without the N? I think I've seen. I think I once kind of like I've never heard of them. Yeah, right. Yeah. Be like, I've never heard of CI and SI. Mathematically gives you the same result. These are called special functions that cannot be expressed using elementary functions. So we give them their own names. Oh, beautiful. Oh, I see. Okay, the sine integral is integral of sine t over t. Oh, I see. I see. Yep. You're totally right. Yeah. Okay. Okay. So, I think you did the majority of things correct. It was just getting to this point, and I wish I could, like, elucidate more on this, but I guess this is something you're just supposed to know the solution is this. I wanted this to be like d squared I dA is equal to negative IA. And then I knew this is the wave equation, which is cool. Yeah. Okay. Well, I hope that helps. I know it's kind of whack, but sometimes that's what happens. I think, and I learned a lot actually. This Feynman trick is super cool. I've like heard of it, but I've never really used it in a question. But it's very cool to see how it works. Yeah. Well, I think that is with the 1 over a, right? When it has the 1 over a, it's that, yeah. We use it sometimes in quantum. That's cool. All right, smart breasticle's done. You reached 10K votes. That's crazy. I guess yeah, because once you get to 1,000, you're able to add like 100. Okay, we have to rebalance the voting system. That's too funny. Okay, so this was, yeah. Well, because you're adding 15%, right? So 10% of 1,000, 10% of 10,000 is 1,000. Also, other people can upvote. Yeah. Okay, so this was. Sorry, whose question did I just do? Breasticles, I know. Breasticles. %, I think. Yeah. Yeah. Okay. I mean, I think it's cool. I'm glad that it encourages the community to like do things and click things. It's really cool. Another thing I coded over the weekend for those that want to, find out when we stream and stuff. If you go to the website here, right, actualofficehours.com, if you go to the streaming schedule here, click on it. This is the new calendar I created. And so really cool thing. It shows everyone. It's color coded. So like Penn Center's red, Zach, E to the 2 iPi is blue, MathPond is green, we're kind of gold, Mavort's also that. But also, there's a little thing here that'll always say whoever's live and how long they're scheduled to be on, and then when the next one is as well. And if you click on it, it'll take you to our stream. Click on it. You can also click on other people's things, and it'll take you to their stream. So it's also in your time zone. Please, for my international people or people that are not in the Pacific time zone, if you can check to make sure it's displaying correctly in your time zone. I think it should be fixed now. It wasn't working earlier. But this should move around to like what your current time is. Because I know that was another complaint that I had from people, is that they couldn't figure out what they're like, okay, cool, you're streaming at 5, but like what time is that in like Uzbekistan? I'm like, well, I don't know. Yeah, breasticles. Okay. All right. We still got time. We got 42 minutes. So Narosky, you want to do this one, Narosky? Time zones are good. Nice. Narosky's typing. Oh, I won't be speaking to help though. Okay. Yeah, let me still. Well, okay. I need to translate this. Translate. I unfortunately don't speak Romanian yet. Okay. A and B are real for which, and P is a natural number, which is. Are natural numbers integers? Oh, they are integers. Okay, cool. Okay, so we want to show the limit as x approaches infinity of this is equal to 2. I think okay, let me think how to do this. I think I move this over to the right. Is this what I do? Well, that limit's equal to 1, right? So this is the third root of ax to the 6th plus bx to the 4th plus 3x squared plus 2. And then I think I can say is, okay, minus x sub p. If I move that over, right, that's equal to 1. And then I want to say I can move this over as well. And say this is 1 plus x of p. And then this is all limit as x approaches infinity. And then I can divide this over, right? So I get... I feel like it's this. Taking the 1 out would be breaking some stuff. Okay, let me see. Let me read what Narosky says. Well, what if the square root of... What if the... Oh, is it... Sorry, is this... Square root... Okay, what if square root minus xp is indeterminate? Taking the 1 out would be breaking some stuff. So I think I'm still including it, though, Narosky, right? If I move it over to the right... Isn't that still okay? Because I'm still accounting for it. And then this is indeterminate form, right? Because this is equal to infinity over infinity. What if p equals 2? What if p equals 2? So then that's minus x squared. How does that make a difference? This is x squared? I guess because, I mean, the highest power of this thing is going to be x squared. Do you know conjugates? Kind of. Are you talking like a plus b and a minus b? These are conjugates. I know you could multiply both sides by the conjugate, maybe. Square root x minus 1 plus x. Yeah, the conjugate of that would be... This? You're saying this? Imagine it as a fraction with denominator 1. Like that? A whole fraction. Okay, maybe like this one. Then amplify it by its conjugate. So multiply. I think I'd be multiplying by this, right? Square root of x minus 1 plus 1 over 1? Is that what we call multiplying by its conjugate? Or you want on the top and the bottom, maybe? Yes. Okay, like that. Okay. All right, sorry, not plus 1. Sorry, plus x minus x, right? Okay. Right, and if I do that, then I end up getting this squared, so that's x minus 1, and then I get minus x squared all over the square root of x minus 1 plus x. Well, that's kind of ugly. So negative x squared plus x plus 1? No, minus x. Oh, okay. Okay. I see. Uh-huh. Okay. So, well, then I gotta think about the rules for cubes. Do I have to do difference of cubes then? Okay, so you're saying like this whole thing here is over 1. And then I'm going to multiply by the conjugate of that. Wait, how's that going to work though? Oh, wait a minute. Okay, wait. Cuz okay. I think I get it. Okay. A cubed minus b cubed I think is a plus b. This was from my competition on Monday.
You're not that guy, Charles.
Oh no.
You're not that guy.
I think this is a squared minus ab plus b squared. So, I imagine like so a is equal to fuck. Oh, it's messing with me. Oh, I think I want to get to a plus b cubed. And then this is a minus b, and this is plus ab. Okay, I think I get it. So a is equal to the third root. Let me give you a hint. What if p equals 1? Because p can be any integer greater than or equal to 1. How does someone have 28k votes in the live queue?
Good job.
They just keep hitting upvote every 3 minutes, and it boosts it by 25%, and they've been doing it for the last hour. And so it's exponential growth. It's actually quite cool. Does a limit exist in real numbers if p is equal to 1? Minus x. So wait, that's minus infinity plus 1 has to be equal to 2. So it's like blah, 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 right? Cube root of infinity minus that has plus 1 equals 2. I mean, if you can get this to somehow, this minus this to equal 1, sure. Then it would. But, I mean, I start looking at the highest powers, right? So, think numerically. Well, I think like the cube root of x to the 6th is the same thing as x squared. So I have x squared effectively minus x to the 1st plus 1, and there's no way. Right? There's no way this works for these to cancel. Yes, good. It's effectively order x squared versus order x. So I think p has to equal 2 at least, right? But they said p equals 2 might work. Yeah. The Americans beat us in women's hockey today. Oh, dear. Yes, I agree P equals 2 might work. This is where I wanted to do, like, L'Hopital's rule, right? And then greater than 3 won't work because then you have x squared minus x to the third. And that'll also never work. Yeah, exactly. I get it. Yeah, because the cube root of ax to the 6th is basically x squared. And how would you write that exactly? Because it's a big deal. I would say that p has to equal 2. Just has to. I guess in terms of like getting points. Yeah, it's probably a lot of points to write out exactly why this is. Minus 10.
Surprise, motherfucker. Surprise, motherfucker.
Oh, no. Ugh. I would say this. I would say this is like effectively this. In the limit as x approaches infinity, right? We don't really care actually by any of the other terms. For that, you can pull out a factor. Ooh, you were actually very, very correct. Yes, I could. So actually, let's do this. Okay. Right. I could pull out x to the third, right? So this is the same thing as the cube root of x to the third. Ax to the third plus bx plus 3 over x plus 2 over x cubed, yeah? Minus x to the p. I think we can just say is equal to 1, right? Can we just say that? Can I move the 1 over? I think I can move the 1 over. And then this would be x oh, actually, no, wait. Let's pull out x to the 6. What am I talking about? Let's pull out x to the 6. Let me do that. That's what I wanted to do. So then, now if I pull this out, I get x squared cube root of a plus b over x squared plus 3 over x to the 4th plus 2 over x to the 6th, right? Minus xp is equal to 1. And then I would say in the limit that x approaches infinity, I can get rid of these. So I would say that x squared cube root of a minus xp has to be equal to 1. Oh, let L equal the limit. Yeah. There's probably some fancy math speak for it, yeah. What's up, Amir? Uh-huh. Yes, infinity if p is greater than 2, and then it's 0, right? If p is less than 2. Oh, sorry, p is less than 2. It's also infinity, right? Sorry, it's just another form. Yeah. So the only way for these to cancel... Yes, okay. It's possible, right? Does that mean A is equal to 1? And then do I care what B equals? Uh-huh, okay. Because if P equals 2, then I have x squared cube root of A minus x squared is equal to 1. So that's x squared cube root of a minus 1 is equal to 1. Wait, yeah, wait. Actually, how does this work? Yeah. Oh, okay, okay. Ooh. Oh, no, wait. No, it's not equal to 1, though. Uh-oh.
Oh shit, not good.
Oh, shit. Oh, wait a minute. Maybe. Fuck. That was a mistake.
Surprise, motherfucker.
You're right. It was a mistake. I made a mistake. I can't do that.
No, God! No, God, please, no! No!
Okay.
No! No!
Okay. All right, we're gonna do that. We'll leave it. We'll leave it. We'll leave it, Narosky. Okay. Okay. So if I have x squared cube root of a minus x squared plus 1 is equal to 2, right? I don't know. I want to do this. I don't know. Does that really help me though? Because if this is 1, then I get 1 equals 2.
Disqualified.
I don't like that. Oh, into the initial limit. Okay, so that was just the proof to show that p had to equal to 2. So then you're saying just go back to this. Yeah. Yeah. Why did the 3 terms? Yeah, so what I did, is for these, I just assumed as x was approaching infinity that these things we don't really care about. Because they'll be small compared to what a is. But I think we could only use that just to prove that p was equal to 2. We can't get rid of them to show that this whole thing is equal to 2. Yes. So as x approaches infinity, yeah, now I have it in a determinate form. Oh, yeah, you're right. No, you're good. You're right. I think this is what I wanted to show. Right, and this is only possible. Well, no, I wanted to show that, like, I still haven't plugged infinity in for here, and I still haven't plugged it in for here. So, I got rid of, like, some of the limit, I guess. So now you have to apply the conjugate. Let me see. Just because I only have 22 minutes left, I still have 3 other questions. Let me pause on this. This is cool. We're getting close though, Narosky. I appreciate like all the help getting to here. But let me make sure I can help the other students out before. Yeah, all good. It's cool. Let me here. I'm gonna save this at least. Pineapple says, I have light questions. What are your light questions? Those are a little bit more than light. I have to like think about those. Eventually you get A equals 1, and then you plug in A is 1, P equals 2, and you can P. Okay, very cool. All right, let's do the vote. Let's choose the winner, because Gladiator has accumulated 100,000 votes. Let's see, dude. If it actually picked one of the other ones, I would have broken the universe. Okay, Gladiator. It's technically you. Okay, great. All right, Gladiator. Let's go to your question. I'm going to try to help as many people as I can real quick here. Oh, you're asking me OChem again. I don't know OChem. Okay. Synthesize the following compounds beginning with propene. Use any reaction type. All my votes are gone. It was cool to see, though. It's cool to see you could rack it up to 100,000. Okay. Is JC here? He's not here. Okay. I don't know how to do this. I don't know how to do OChem. If anyone in my chat does and you want to help out, please do. What's up, Sam? How's it going? Yeah. Wait, you just heard your name jump scare? Okay, JC's your guy. He was playing Minecraft. He's lurking, dude.
That's dope.
Shout out to JC. JC's awesome. Bless you, JC. JC, do you want to help out on this one? Oh, it's Chem. Yeah, that's why. Yeah, I mean, we like calling out your name regardless, but they want to synthesize this from propene. WJC. Okay, I'm gonna post this in our Discord. So JC, if you want to take a look at it, and then I'll pull the solution up on if you do it. There you go. He says adding benzene with H3PO4 catalyst. All right, let me go through. Let's see. What else we got? In terms of... That's the stream schedule. Okay, spin. DM's been waiting a bit. Looks like it's going to be DM's creator. Yes, much love. Good evening, Norowski. Yeah, have a great night. Appreciate you coming by. Alright, let's help out DM's creator. I have a quiz on arithmetic and geometric sequences tomorrow. Can you explain it for 5 minutes? Okay. You did at least write it out as a screenshot. Okay. So arithmetic sequences means there's like a constant difference between terms in the sequence. Okay. So the key thing here, right? For example, like 1, 3, 5, 7, ... Because it's like plus 2, plus 2, plus 2. The mirror, or the other one to this, is called a geometric sequence. Geometric. Which means that there's a constant ratio. Or we call that like a multiple. Okay. And so that it would look like something like this. Let's say like 2, 6, 18, 54. Because this is times 3, times 3, times 3. Okay. Yes, if I get to you, Pineapple. I have to go by what's in the queue. If you submit the screenshot, though, you have the best chance of it getting answered. Just post one of them in the queue and hit upvote or something. Just for my own sanity, because we're live on so many different platforms that I have to have like one single place for all the questions. Otherwise, nothing would ever get solved. Okay. That's okay. And then, so the form for like the terms, this would be an is equal to a0, and then you would say n times d. So that's like what term you're looking at. And then this is the difference. The other way they write this is they would say that like an plus 1, or like an is equal to an minus 1 plus the difference. Two different ways to write it. This way, I think, is a sub n is equal to a0, and then it's r to the n minus 1, where this is the ratio. Or you could also say that an is equal to r times an minus 1. Yeah. That's kind of all you... That's all you really have to know for the sequences. When they ask for the series, like in terms of the sums, then we can do that later. And that's like s sub n. This is s sub n. There's different things for these. But okay, cool. Hope it helps. Okay, DMs. Oh, and then Gladiator, you definitely get a bond coin for for racking up 100,000 points. Okay. Let's choose the next winner. Spin, spin, spin. Who's it gonna be? Gonna be Anthony. See, now it seems to be going in order. Cool. Okay. Okay, the average daily level of carbon monoxide can be modeled as this function. Okay, it is estimated that T years from now, the population, the population of the community will be that 1,000. At what rate will the carbon monoxide be changing with respect to time 3 years from now? Oh, this is like function of a function. Okay, so they want... Oh, this is cool. This is a chain rule, actually, Anthony. So they want to time. So they want dc dt at t equals 3. Which, because c is a function of p, this is dc dp times dp dt. Okay. Chain rule. You could have also just like plugged this into here and done it, but that would look kind of weird. It just looks ugly. Okay. So this is ddp of 0.5 p squared plus 17 all to the 1/2. And then this is ddt of 3.1 plus 0.1 t squared. Okay, so let's do the derivatives. So this one, bring the power down. So that's 1/2 0.5 p squared plus 17. And then drop the power, right? So to the minus 1/2. And then plus, this ends up equaling just 0.2 t. Okay. And then we need to evaluate this at t equals 3. But then also remember that p was equal to 3.1 plus 0.1 t squared. So p of 3 is equal to 3.1 plus 0.1 times 9. So that's equal to 4. And then here, this would just become 0.6. Okay, so we're almost there. So you end up getting 1/2 0.5 times 16 plus 17 all to the negative 1/2 plus 0.6. Okay, so 0.5 times 16 is 8. So 8 plus... Oh, actually, I can do all this in my head. What am I doing? Because that's 8 plus 17, which is 25. Oh, this is actually really cool, actually. Oh, we don't even need the calculator for this. Sorry. I was getting... Right. This is 8. 8 plus 17 is 25. To the negative 1/2 is equal to 1/5 times 1/2. So it's 1/10. We did shush. We did. Plus 0.6. Well, that's 6/10. Okay. So the answer is 7/10. Cool. And then the units is it's carbon per unit time. So this is like ppm per year. Okay, nice. Good? Cool. Let me know if that makes sense, Anthony. That's kind of a cool one. It's a chain rule question.
Well done.
You're stuck on an integral. Oh, okay. Try putting it in the queue. We'll see if we can get to it. I got 9 minutes left. I'm speed running as quick as I can. Okay, let's see. Let's go pick the next winner. So now it's a little bit more even. A little bit more even. Who's it gonna be? Willie Manelli. Okay. Ooh, this is fun. All right. You can break this up into 2 integrals just to start off with. So I could do 6 to 0 of 2e to the... It was very even. E to 1/3 x dx plus integral of 6 to 0 of 2 plus 5x. Oh, sorry, 5x. 5x e to the 1/3 x dx. This is easy. This is just u sub. But this gets you 6 e to the 1/3 x from 6 to 0. Which, interesting, going from 6 to 0. So you plug in 0 first. So that's 6 minus e to the 2x. Right, or e squared. Okay, that's that first part. It's bothering me that you haven't made it 0 to the 6th. Why? Wait, what? Okay. So this was U sub. This one is going to be integration by parts. So we're going to say u is equal to 5x. du is equal to 5dx. v is equal to e to the 1/3 x dx. Or sorry, dv. So
v is equal to 3e to the 1/3 x. Integral from a to b is negative b to a, correct. Yes, yeah. Oh, I see what you're saying. Negative 0 to 6. Yeah, whatever. I just did it from 6 to 0. They left it as 6 to 0. Yeah, okay. So then, this is the integral of uv. Or sorry, that's not integral. It's just uv. So that's going to be 15x e to the x over 3.
from 6 to 0. Minus integral of v to u, which is minus 15 e to the 1/3 x. Okay. This ends up being 90 e squared from this one. And then this is just going to be minus 45 e to the x over 3 from 6 to 0. Which is just 90e squared minus, plug in 0, you get minus 45 plus 45e squared. Okay, and then you gotta combine these both. So, let's see, we got a 90e squared and a 45e squared. That's 135, but then minus 1. So I think that's 134 e squared. And then I have a minus 45 and a plus 6. So I'm going to say minus 39. I think that's it. Cool. I believe I did that right.
Well done!
I'm doing things very quickly on brain fog. How do you add to the queue? There's a website, actualofficehours.com, right there. You just submit a screenshot. It'll let you do it. Last 10-minute clutch. Yeah, well, last 4 minutes, I think. Last 3 minutes. So I might not have time crazy run. But yeah, the way you would do it is there's this website here, actualofficehours.com. You just drag it in. You're welcome, willy-nilly. Also, yeah, so check out our streaming calendar here. If you click here on streaming schedule, this has all the different streams that are happening with all our awesome math friends. So you can check out, make sure to go follow, like all the stuff. This is a cool little thing we did. All right, let me see real quick. Lucky Cat, we got to spin. We got to spin. You have a 100% chance. Just to do it. Oh, it's kind of fun. Lucky Cat's you, dude. Winner, winner, winner. Okay, good. All right. Yeah. I got you, Pineapple. Thanks for playing. Wait, did you want all... Let me just do all 4 of these real quick. This one. The remainder theorem. That's a fun one. Okay, let's go through them. Okay, that in descending order. Oh, what does descending order mean? Like descending order of powers, maybe? I think it would be this one. That seems to be like the correct. I mean, usually you want like higher exponents down to lower ones, yeah. The other ones don't really make sense. X minus k is a factor if and only if f of k is equal to 0. Ooh. Can you count backwards? Question. Okay. If x minus b is a factor of g of x... So let's think about how this works, right? So if g of x can be composed as, like, something else, and then, like, x minus b, that means if x is equal to b, like, if you were to plug that in, this whole thing should be equal to 0, right? Because this would be equal 0, right? Because then you would have, like, b minus b is equal to 0. So this should also be 0. Then g of b is equal to 0. I mean, I feel like yes. If h of c is equal to 0, then x minus c is a factor. No, that's not true.
Bruh.
That's not necessarily true. Or is it? Well, I want to talk about, like, if you had, like, for instance, like, sine of x, right? You know, x minus c is a factor. Yeah, it's only if it's a polynomial, exactly, right? Yeah, exactly. So, I mean, this is kind of a trick question. Only if h is a polynomial, yeah. So I'm tempted to say no to these and to say that this is the only thing that's true. Because, yes, if it's a factor, then it has to be equal to 0 as the function. Okay. A division has a remainder of 0, which the quotient and the remainder are factors of the dividend. Oh, man. Dude, what? Ugh. One second. Let me look at this one. When f of x is divided by x minus k, then f of k is equal to the remainder. No, I remember what this is. So if you have f of x divided by... So this is going to equal to something, and then it's like plus a remainder. And so if you divide this by x minus k, then that's equal to this, x minus k, over this, x minus k. Oh, actually, no, sorry, this is how it works. This is called the remainder, but it's really equal to this over this. Now I remember what you do. So then f of x is equal to blah, 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 x minus k plus just the remainder. So then if you plug in x is equal to k, then f of k is just equal to the remainder, right? Because then this goes away. Okay. So when it's divided by x minus k, f of k is equal to the remainder. I believe that's correct. When it's divided by jx minus k, then k over j is also the remainder? Interesting. Well, this is the same thing as j x minus k over j. Yeah, these are not fast, easy questions, Pineapple. He's like, these are some light questions. They're not light. They're mind fucks. Yeah, they're not light. Yeah, it's just annoying is what it is. I think this is also true, cause like, yeah, who cares, right? It's the same thing. You're still multiplying by whatever the factor is, which is the thing you divided by. So yeah, I think A and B are true. I think both. This one, I forget what like divisor and quotient and remainder are, but if it has a remainder of 0, then yes, the divisor and the quotient are factors of the dividend. Yes, I believe in this. Cool. Right? Because if this divided by this gets you just this, then you could move that over. And then this is a factor and this is a factor of this. Okay, cool. I think it's right.
Done! Well done!
You're very welcome. Thanks for submitting them. They're cool. Yo, Professor Rossi, I took your Physics 5A class last year, and you were such an engaging professor. Appreciate that.
Bing, 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 bang.
Yois. I ended up liking physics. If possible, could I get your email and ask you about some stuff regarding postgrad? Yeah, fuck yeah. Of course you could. Where can I type my email for you? Here you go. Yeah, there's my email. I'm glad you like physics now. You ended up liking physics. Yeah, most people hate physics. Try to make it so people don't hate it. Yeah, I've written a couple of letters of rec for people too, actually. So if you need a letter of rec too, I got you. All right. Technically, Ayer, I really need to go, but I will do this one for you. Physics is greater than chem. Yeah, physics is goated. I'm gonna be late to something, but I will do this. I think I can do this in 10 minutes. Okay. E to the arcsine of x dx. You're very welcome, Yois.
Good job.
JC's like, no. Chem's much better than physics. Okay, e to the arcsine. I feel like this is integration by parts. Right? Can we say it is? I think it's integration by parts. I like calc problems because there's less reading. Well, it depends on the type of question sometimes. My goat.
Good job.
Yes. Let me see. I'm gonna have Gemini like give me some hints on this one. You do U equals the arcsine? Okay. Let's do it. Wait. You want to do just U sub? Okay. Let's just do U sub. I think this is a cute trick, actually. Yeah, if U is equal to the arcsine of x, right? Okay. Then du, what's the derivative of arcsine? Is that 1 over 1 minus x squared? Yeah, this is what I do. Ooh! There we go. Oh, okay. Wait 1 sec. U equals arcsine of x. Well, let me write this out first. Okay, so du, or I think I see what you're gonna say. So x is equal to sine of u, right? This is actually a really cool trick. Yeah, if I take the sine of both sides, sine of arcsine cancels each other out. And then you're just left with sine of u is equal to x of u. Or sine of u is equal to x. Okay, then here's a cool thing. Yeah, watch this. So, dx is equal to cosine u du. What's up, Fembox?
Good job.
Right? Okay, so now let's rewrite this integral. So now I have e to the u, and then dx is cosine u du. Oh, beautiful. What did I join to? Yes, and now this is double integration by parts. It's cyclical. It's actually kind of cool. This works. The problem is that like we used everything in terms of u. I'm gonna say okay. Pretend. Okay. Yeah. I'm gonna here. Let me make these a little different. Let me say this is like z. Because u and v get used in integration by parts. Yeah, this is where the diagonalization method looks a lot nicer. Yeah. That's actually really cool how that works. Okay, so then u is equal to e to the z. du is equal to e to the z dz. V is equal to cosine z dz. Or that's dv, sorry. So then v is equal to sine z. So you get all of this is equal to uv. So that's e to the z sine z minus the integral of v to u. So minus e to the z sine z dz. Do another integration by parts. Here we're going to say that u is equal to e to the z. Du equals e to the z dz. dv equals sine z dz. So then v is equal to negative cosine of z. So then that gets you uv. So you get negative e to the z cosine z minus integral of v to u. So minus minus, that's plus e to the z cosine z. You're on a plane leaving now? Ooh, very cool. It's our Fly Compton crew. What's going on? I need to work on that video for you guys. It's on my list. It's on my list. Don't worry. Okay, cool. So then all of this was up here. I forget the D. I know. It's this method or something, and then you do a bunch of these things. Yeah, I just forget it. So e to the z sine z, and then minus minus. It's gonna be a plus. So we can say plus e to the z cosine z. And then this is minus this, so minus this integral. But this is all equal to the original integral we're trying to figure out. That's the cool part about this question. Notice how, like, the very integral we're trying to solve shows up as an integral in the solution after you do integration by parts twice. So now, you can just move this over. And so you can say, okay, well, 2. Yes, you can literally just do, 2 e to the z cosine z is equal to all this. So e to the z cosine z is equal to all this over 2. But then there's some key things here. But remember, you gotta remember this. Right. But you gotta remember that z was arcsine of x. So this is equal to e to the arcsine of x. And then this is going to be sine of arcsine of x. And then this is still over 2. So remember this from like way over here. Well, here, actually, let's make a different color. Remember. And then that's plus cosine of arcsin of x. This goes away. Sine of arcsin is just x. So you have e arcsin of x all over 2. And this is x plus... This one you got to draw like a little triangle. So... Arcsin is opposite over hypotenuse. So x1. And this is like arcsin of x is the angle. And so then this would be the square root of 1 minus x squared by the Pythagorean theorem, right? Because this squared plus this squared would get me 1. And so cosine of arcsin of x is the adjacent over the hypotenuse. And so that's equal to the square root of 1 minus x squared. And there you go. That's it. Full thing. Kind of an involved question, but fun. There's a lot that goes on. You gotta do u sub, you gotta do double integration by parts, and then you gotta remember inverse trig. Kind of a mess. How many hours in the stream? It's ending. It was supposed to end like 3 minutes ago, or 10 minutes ago. Okay, cool. Hope that made sense. So another key thing is anytime we do one of these questions, they always get put into our Discord. So if you were watching AAER, I'm going to post the solution right there for you. And also the nice thing is there's a link here with the YouTube recording to what we did and the timestamp when it happened. So you can go check it out later. Okay, that being said, I really got to go. So let's close out the stream.
That's dope.
Thank you everyone for coming to Actual Education Office Hours. Appreciate all the questions, all the help. You guys are great. Our next stream will be on Friday, but that won't be an educational stream. That's going to be a fun, like, gaming stream. You can always check out when we're streaming by going to actualofficehours.com. I'm glad you came here, Fembox, too. Click on the streaming schedule. Here's the calendar. So it looks like the next stream that's happening will be Penn Center tomorrow morning at 7:30 a.m. Early bird. We have a gaming stream tomorrow. We're going to do a chess tournament. So if you like chess and you want to compete in a chess tournament and win some prizes, come by tomorrow. And then our next tutoring stream will be on Sunday at 5. So as always, yeah, make sure, go join our Discord. It's the best place to find out about all the fun things we're doing. And also make sure to follow us on Twitch, even though Twitch was messed up today. But we still stream. We're going to go raid somebody. Then I got to go. Let's see. Who are we raiding today? Arduino says he's going to be big. He's going to be back. Melissa in Denial. She was cool. We raided her last time, actually, though. Shark Geek. Cool. Let's go catch up on Shark News. We love Shark Geek. He's a cool guy. Does cool things with sharks. It's going to finally be Friday tomorrow. All right. Enjoy the rest of your Thursday. We will see you on Friday for the chess tournament. Otherwise, we'll see you on Sunday for homework. Peace.
For all of the sharks that they caught or that stole their fish were on the dummy one, which was the Zeppelin that had no magnet inside. So the success rate was very high for that. Actual education! What is up? All right, you run, man. I appreciate you.